And so on the KMP algorithm, for track, we have this next table. And so what I wanted to do is I wanted to give some kind of meaning to these numbers. And I don't think we quite got there on Wednesday, am I right?
Right.
We didn't quite get to the, so we noticed that if you look at all this bunch of numbers, if you look at these 3 examples here, or the 4 examples here, 4 or 3, 4. 4 examples here, all of them, what's the same? What's the same in all of them? Look at the next tables. What's the same in all of them? They're all different, but something's the same in each case. And that is the first entry is always a -1. Notice that in this case, it's a -1 in the second one, but all the other cases it's 0. So why do you think that's -1 and these are 0? What's the same in all 3 of these?
Same character.
Same character B. What if this character was a D? B, B. Do you think that would change to 0? No. Because we don't really care about what character it is. All we care about is how it's compared to other characters. And we are going to process the next table from the first position to the last position. So if I look at the first character A and the second one is D, all I know is that the D is what? Different than the A. So therefore, a D would be the same here. Now, this D is a different story because this D follows another D. That's a different story. But the bottom line here is -1 goes to all of them. So the first character just gets -1. The second case is if the character is the same, it stays at -1. And if it's different, it goes to 0. Everything else, not so obvious. We can also see that if the third character is also the same as the first 2, it still stays -1. So it looks to me like if we had a string of all A's, the next table would be all -1s. Well, just think about what that means. Let's say we have a string AAA. AAA, okay? And we're going to compare. We're going to try to, so we're going to pattern text, tick, tick, tick. Okay, let's say we compare to match, match, it's a mismatch on character number 3. So, will it be beneficial for me to slide the pattern by 1? Why not? Because now I will mismatch on second character. Does that make sense to everybody? I know. My fingers are not as good, but so if I have A, and I match, match, mismatch, if I slide the pattern once, since all of these are A's, instead of mismatching on match, match, mismatch, I'll go match, mismatch. Okay, so, should I slide it twice? No, because then I'll do what? I'll mismatch immediately. Okay, so basically, what you're telling me is that if my pattern is AAA, and I mismatch on the third character, sliding once and sliding twice is going to be useless. Therefore, what do you suggest? Slide 3 times to what position? So if I start at text 0, pattern 0, 0, 0, 1, 1, mismatch, the value of the pattern, which is J, 0, 1, 2, and I, 0, 1, 2, the two 2's mismatch. So the question is, where do I go next in the pattern, and which position do I go to in the text? So in the text, I should go to a position what?
3.
No, there's no 3. There's 0, 1, 2. It's AAA in the pattern. Position 0. I should go to 0. And in the text. Okay, that's where you get the 3 from. Didn't put the 2 together here. So we should go with text going to position 0 against pattern. I'm going to get you on that one. Okay, text position 0 should go against text position 3. So let's just see what we just did. And let's just we'll try a couple experiments. So that means, so if I and J start at 1, and we have a match, match, miss, then what happens is the J, which is the text, J, which is the text, goes to 3, 0, 1, 2, goes to 3, and the pattern slides with 0. Okay? Let's see what would happen if we did this. If we did, so same text again. Pattern, we don't know what it is, but same text. So now we have match, miss, AAA, match, miss. Can we slide once? No, because if we slide once, we're going to get miss immediately. Can we slide twice? If we slide twice, what is the text index? Text index?
2. 0, 1, 2.
2. And what is the pattern? What is the pattern? 0. And before, it was 0, 3. Now it's 0, 2. Okay, let's try the very basic ones. Let's say we mismatch on the first character. Can we slide once?
Yes.
Okay, so that means my pattern goes to index what? 0, and text goes to?
1.
Okay, so let's see if we can generalize what has happened. So this is now in the case that we have the same string of the same characters, right? So tell me what is the same relative to the examples. Relative to the examples, what's the same in all three of these examples? What's the same? Let's just think what happened here. We start with 0, 0. We mismatch. The next comparison, and I'm going to say pattern to text, is going to be 0, 1. Second example, we match on 0, we mismatch on 1. The next comparison is 0, 0, 2. Last example, match, match, miss on 2. The next example is going to be 0, 3, 0. So it was 0, 1, 0, 2, 0, 3. What's the same relative to the examples? That's true, that's true, that's true. But that is not an answer that's relative to the example, but that's absolutely true. So we notice that in his case, with the -1, the pattern always went to 0. Okay, now relative to the examples, what happened with the index J? It's a very easy answer. Think about the three examples, where J mismatched and what J was for the next.
The mismatch index plus 1.
Say again?
The mismatch index plus 1.
The mismatching, right? Okay, so J, remember, let's look at the example, match, match, miss. It was J was 0, J was 1, J was 2, J went to 3. Second example, match, miss. J was 0, J was 1, J goes to 2. And in the last example, miss immediately, J was 0, J goes to 1. So relative to the examples, on a -1, what happens to J? What happens to J on the mismatch? Let's say we miss at character J with a -1 in the next table. Where's the next J value? So far, what we've seen. What happens to the J value? It just goes to, okay, we mismatch on J. So what's the next value?
J plus 1.
Thank you. So difficult. I could just say it, but it's better if you come up with it. Okay. So on a mismatch on a -1, J simply proceeds forward. But I, which is the index of the pattern, always goes where? 0. So now we get the idea. So -1 seems to indicate that the pattern goes to the first position, which is index 0. And the text goes to the next position after the mismatch, which is index J plus 1, assuming the mismatch happened at J. Okay, now let's take a look at this one, because we know that since the next table is generated like this, we generate this and this before we ever look at the character C, which means that the next table for AB will be -1, 0. So I'd like to see what's going to happen in this case. Actually, let's look at ABC, shall we? So if we look at ABC, what's the next table? -1, 0, 0. So now let's look at the examples. We are having the pattern of ABC. I is 0. Let's say text is 0. And we mismatch. And the -1 rule from before tells us if you have a -1, what's going to happen? What's the next? So 0 against 0. I against j is a mismatch. Where does I go to? I goes to 0 and j goes to, which tells me that we should, what are we doing effectively when we do that? When the pattern goes to the first character, which is 0, okay, and the text goes to 1 after the mismatch, which is j plus 1. So that means that we are effectively doing what?
Restarting our search.
Let's get an eyelash just bumped my eye. It's going to be a lot of fun to watch the video. Hey, look at him, he's going crazy. All right, I think it came out. Okay, so what happened is that we did a slide by 1. Because we were at 0, 0, we mismatched at 0. So the pattern went to 1 and the text went to 2. Slide 1. That's what we did, which is, does that make sense? Does that make sense? We mismatched on A, so we did a slide. Oh, yeah, it makes sense because the A could match the second character in the text, right? So it makes sense. So let's think about what happens with these zeros. Now we have B and C. So now, in order to trigger the 0, find out what's going on, the same thing should happen relative to the ij values. The same thing should happen on the mismatch on B as it does on the mismatch on C. So let's take a look at an example. ABC is the pattern. Text is whatever. We're comparing pattern 0, and I'm going to say against text J. Okay? So 0 against J. It's a match. So now we're going 1 against J plus 1. And now we're going to go, it's a match. Now we're going to go 2 against J plus 2. It's a mismatch. So we mismatched on the last one, on the C. Does it make sense for us to slide once? Why? Because A would mismatch with B, because A and B are different. How about slide 2? Well, let's see. If we slide 2, the A would not go to the B location, it would go in the C location. C, what happened to C? C did a mismatch. What was the value of last value of J? What was J plus 2? Okay, so it seems to me a slide of 1 is no good, because A matched A, and if B matched B, then A can't match whatever B matched, so that's a waste. But this is a possibility. Because we know that C mismatched, but we don't know what it mismatched with. So therefore we should slide twice. So let's see what happened. So A, B, mismatch. A, B, mismatch. We slid twice. What happened to J? Compare the J for the next comparison against the J of the mismatch. How does the J of the mismatch compare to the J of the next comparison? They're the same. So what we're saying here is, what Ed is saying is that the J, or the index of the text, doesn't move. It moves. Compare A, go to the next one, check, go to the next one. Don't move it. We're going to match to it. So, but which is the pattern index that goes next? Zero. Okay. That happens on C. What happens on B? So let's say we match on A, we mismatch on B. Could we slide once?
Yes.
Why? Because B mismatched on something which could be a match for A. So then we slide once. So let's see what happens. So the pattern index for the next comparison goes to 0. And the last J value stays the same. So it looks to me that's what's happening here on the 0. So the 0 indicates to me that we start with the 0 index on the pattern, and the index of the text stays the same as before. Here same, here same. So what's the difference between -1 and 0 then? Because both, what's the same on -1 and 0? What's the same?
Sorry, next goes to 0.
Pattern, the next of the pattern goes back to 0. So 0 means the pattern, the next pattern comparison is 0. 0 means the next pattern comparison is 0. -1 means the next pattern comparison index is also 0. But what's the difference between them? In this one, the j value goes up. Here, the j value stays. Okay, so now we are thinking, and now in order to really see if we can generalize this, I'm going to show you, and you can see by yourselves, that actually, you can see it by yourselves, is that sometimes the values are -1, sometimes the values are 0, but the other values are positive integers greater than 1. For example, we observe a 2, here's another 2, here's a 2, and here's actually a 4. So let's see what's going to happen in this case. You want to go for the big 4? Let's go for the 2. Let's look at this pattern. When is that 2 going to, when are we going to have to act on the 2? What's the scenario that we act on the 2? When I of the pattern is equal to what? When are we going to act on this 2 value? When I of the pattern is what? What's I equal to?
5.
5. Because that means this is index I is 0, 1, 2, 3, 4, 5. That means when I of pattern is equal to 5. And the value of the text, because we could be anywhere in the text, we're just going to call it j. So that means that 5, index 5, is mismatching with the value of j in the text. So it means that this D did not match. But it also means that A, B, C, A, B, D matched. So therefore, let's take a look at this and see what if we can generalize this. So we had a match, 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 mismatch. Is it worthwhile for us to slide it once? Yes or no? No, because A cannot match B. How about twice?
No.
No, because A cannot match C, which have already been matched. So one slide for A is this, 2 slides for A is this. Is it worthwhile for us to slide 3 times?
Yes.
Well, it is, but it isn't. Tell me why.
Because C doesn't match B.
No. It's a different answer. It's not worthwhile for a different reason. Not because we know it's not going to match, but because we know it's going to match. Because we know that if we slide it 3 times, 1, 2, 3, then this A matched previously, so this A will also match it. So why should I compare it? Now, is it worthwhile for me to slide it? So let me change the question because I think I misled you a little bit. We don't have to compare A against AY.
We know that.
We know it's going to match. In fact, if we slide 1, 2, 3 times, these are going to be matching. And also we know these are going to be matching. And what about C and D? Do we know about that? Well, all we know is that D was mismatched. And what else do we know? That D follows AB, C follows AB. Okay? Therefore, if I slide it 1, 2, 3 times, this A will go in this position, this B will go in this position, and this C will go in this position. Could the C match? Yes. So therefore, the slide of 3 is worthwhile. Now, what should the index be for comparison? And the answer is the index should be 2. Therefore, index 2 is 0, 1, 2. That means we should compare. So if we mismatch I is equal to 5, and this is J, 5 in the pattern, J in the text, what are the two indexes to be compared? What's the two indexes? Pattern to text. 2 and 2 and J. Which means that wherever we mismatch on J here, we're going to freeze that. We mismatch this D, we're going to slide the pattern 3 times, but we're going to start the comparison C, which is going to be in position of D, and try it there. So if we mismatch, so now that's a general, now see if that makes sense to us. Let's look at this 4 over here. Imagine that we match everything here, except we have a mismatch right here on this character. So that means that we want to compare, the next comparison would be index position 4 on the pattern against what in the text? J. 0, 1, 2, 3, 4. This is the next comparison. So how much slide is that? 6. There's actually a slide of 6. So we want index 4, 0, 1, 2, 3, 4. Now why are we going to compare here? Because look what goes before the D. Before the D, we have A, B, C, A. Look what happened before the mismatch here. A, B, C, A. A, B, C, A, match, 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 mismatch. So therefore, since I have A, B, C, A, followed by B, and here I have A, B, C, A followed by D, then the B might match whatever the D did not. So, to generalize everything now, there are 3 things that you can find on the next table. If you have a -1, you always go back to pattern 0 against text what? J plus 1. If you have a 0 in the next table, it always means pattern
0
against text J. And if you have a number that's a positive integer, it's going to be pattern positive integer and text J. That's the sequence. Okay, so that's how that works. Now, to do that, this is the algorithm. And as I mentioned, it's not obvious how it works, but let's just go through a little bit of it just so you can see how these next tables are built. Okay, so what we have here is the first thing we do, notice that algorithm immediately puts a -1 into the first entry, so all of them will have -1s. Because if you mismatch the first character, you don't know what the second character is. Therefore, you have to try the first character against that second character. So you're going to try the first character again in your pattern, which is 0, against the next character in the text, which is going to be J plus 1. So that's why we put a -1 here. Now we're going to have a couple of variables going on here. K, we start with -1, and J. K and J are going to be doing the indexing within the pattern itself, because the next algorithm only considers the pattern. Doesn't know what the text is, doesn't care what the text is, because the text could be anything. So we initialize K as -1, J at 0. We repeat while K is not equal to -1. Well, K is equal to -1. So therefore, what happens to this? Nothing. This loop does not execute at all initially. So K and J go to what values? K goes to 0 and J goes to 1. So 0 and 1, K and J, 0 and 1. Now look at this pattern, 0 and 1, 0 and 1, right? So now we compare pattern 0 against pattern 1. In this case, they are the same. In that case, next of 1 gets the next of 0, and you can see how the minus 1 is just copied to the next location. But in this case, A, B, we have the else condition because they're not equal to each other. So therefore, the next of j, which is the next of 1, is the value of k, which is 0. So we can see how that's going on here. Okay, so, and of course, until j is equal to the length of the pattern, notice that j is incrementing unconditionally. That means that this loop is going to happen for j is equal to 0, j goes to 1, 2, 3. This is what's going to kill the loop. The loop is going to come out when j, and what's j going to go through? The length of the pattern. So we can see right away that the j is moving, but the k is doing some funny stuff, which is fine, because the j is controlling the loop. So as we go up here, what is our value of k and j? So our values of k and j are 0 and 1. Still, 0 and 1. That's what they move to. So now, let's trace them through the A, and the ABC. See how they behave differently. So what's the value of j? J value is 1. So now k value is, let's look at this pattern. In this case, we also assign the same, that's a true condition. The next j is equal to the next k. So let's assume this happened on the iteration, on the first iteration. Now k not equal to 1 is a true or false. That's true. So, is this loop going to iterate? Is this loop going to happen or not? The second time through. This is the outer loop, it's the inner loop. Is the second time through, is the inner loop going to iterate? K was -1, K went to 0. Okay. We got assignments here. What's the value of K? Is 0 not equal to -1 or equal to -1? Not equal. Okay. So therefore, what's the value of K? No. Okay, you're not following? The value of K is 0. 0, not equal to -1. This is P what against P what? P0 against P1. Is that true or false? They're not equal to each other. In this case, not equal to each other. Not equal to, are they not equal to each other? PK not equal to PJ, yes or no? Did you forget K and J already? What's the value of K? What's the value of J? Thank you. What's pattern 0 against pattern 1? True or false in this string?
False.
No. They're not equal? False, they're equal. So do we do this?
No.
No. So what does K go to? 1. What does J go to? 2. So J and K, or K and J, are going to be 1 and 2 respectively. 1 and 2. This pattern 1 equals pattern 2. Yes, so therefore, the next of 2 is the next of 1. You see how that gets created? Okay, now let's go backward. So we're going to go to this one. We're going to go to this one. So we put a 0 here. We got this idea here. What's the value of, now we're going back. So now you have to remind yourself, what's the value of K and J coming into the second repeat iteration? 0 and 1. Okay. So K is equal to? Not equal to 1. True or false? True. P0 not equal to P1. True. Therefore, K is equal to the next of 0. What's that equal to? -1. K gets -1. And we're going to loop. Do I repeat the loop? No, because K is equal to -1, and therefore K not equal to -1 is false. Where does K go to? 0. Where does J go to? 2. 0 and 2. So now we're going to compare P0 against P2. Equal or not equal in this example? Not equal. Not equal. So they're not equal, so therefore the answer is a false, right? So next of J is equal to what if they were equal? What does that mean if they were equal? Then if they were equal, the next of 2 would get the next of, if this was an A, what would it get? -1. Okay, because 0 and 1. So in a sense, what we do is we process and we try to match for each current character, we try to match what's going on before it. And that's how it works. So that's how you get -1, -1, -1, -1, 0, 0, -1, 0, -1. Why does this? So let's say we get -1, 0, 0. So we know how that's coming about. So what's the value of j and k in this case, for the 0 case? J is 2, k is? K is 0. Okay. So now we're going to come up here. So remember, 0 and 2. So k is 0. Not equal to 1? Okay. Compare pk and pj. True, not equal or equal? Because? A and C, right? So k is equal to the next of k. So k gets to the next of k. What's k? So what's the next of k is going to be what? -1. Where does k go to? 0. And j goes to? 3. 0, 1, 2, 3. So now we're considering this case right here. Is pj, which is p4, equal to p0? Yes. So what does this value get? It's a -1. Okay. So now we're going to go up. What's the value of k and j again? 0 and 3. True? True. P0 not equal to P3. P0 not equal to P3. 0, 1, 2, 3. False. What does k go to? P goes to 1, j goes to 4. P4 against P1. P4 against P1. Equal? Next j, next of 4 gets the next of 1. That's how that 0 gets put in here. What's the value of k and j? 1 and 1 and 4, right? J is 4, k is 1. K not equal to -1. What's the index of k? P1 not equal to P4. 0, 1, 2, 3, 4. It's going to be false. So what happens here? K goes to? K goes to 2. J goes to 5. 2 and 5. 2 and 5 equal or different? They're different. Therefore, what do we get? Next j is equal to 2. That's what this 2 gets put in. A little strange, right? It's a little interesting algorithm.